Hey, CW Apes, Mr. Kennedy here with part 2 of your chapter 15 notes on renewable energy sources. So in the first part, we talked a lot about transportation, efficiency, energy efficiency, finishing up with, solar power. So in this section, we're going to look at some other alternatives like hydroelectric power, biomass, all that stuff that, we can use to generate electricity cleanly and safely for generations to come. So the first thing that I've got for you here is a picture of something that hopefully is familiar to you. This is Friant Dam, and believe it or not, it generates electricity through the use of falling water. Let's kind of explore hydroelectric power through the lens of dams. In 1925, falling water actually generated about 40% of the world's electric power. So that doesn't sound like much, if you think about, 1925, what was the population, what was the energy use, all that. But over the past several decades, hydroelectric power production capacity has actually grown 15 times, 15-fold what it was in 1925, which is awesome. The only problem is fossil fuel use has risen so rapidly that even with the increase in production of hydroelectric power, we could still only supply about 20% of the electrical generation needs of not just the country, but the world, really, when you think about hydroelectric capacity. Norway uses hydropower for about 99% of its electric supply, but Norway's got like lots of access to water that, some parts of the country that just straight up don't have. So there's that we also have to deal with when it comes to hydroelectric power. There are some huge untapped resources in Latin, Central America, Africa, India, and China, but all of them come with a huge list of pros and cons. Realistically, in order to access hydroelectric power and to do so efficiently, more often than not, dams are employed. Dams serve lots of purposes. I mean, people build dams, to control floodwaters. People build dams for irrigation and just water storage for times of drought. But when it comes to hydroelectric power, really, this is the best way to produce lots of power, like really, really quickly. But there's a huge laundry list of cons that go with dam construction. It's expensive, right? And then there's the environmental, like ecological disaster that they sort of create. Let's take a look at some of those things. If you build these mega dams, even Friant can be considered a mega dam. There's human displacement that is almost always involved. Millerton Lake and Friant, the town of Friant, are a great case in point that is local. The original town of Friant is not where it is today. The original town of Friant is actually at the bottom of Millerton Lake. If you were to drain that lake, you could probably still find some of the old buildings that made up the town of Friant. So, when geologists come through and they say, okay, well, we're going to build a dam, hate to break it to you, but, you're going to have to move. You're going to have to move. You don't have a choice. There's ecosystem destruction, wildlife loss. You're going to flood a terrestrial landscape and trade that off for an aquatic one. As you flood that, you get rotting vegetation that can acidify the water and cause fish kills and things like that. You get sedimentation behind the dam. It disrupts nutrient flows downstream. It could disrupt fish migration. There could be pollution associated with the, recreational use of the waterway, and herbicide contamination if people start, using that water for agriculture. So there's all kinds of negatives associated with building the dams. And as I'll show you in a few more slides here, maybe we might eventually get to a point where we just don't need to build dams in order to still get electricity from water. Okay, this is how the hydroelectric power plant works from an inside view. So basically, as long as the intakes behind the dam are, above the, water level where they can pull water in and not have to worry about sediment getting sucked in and all of that. We take a gravity feed of water through the dam to a power plant on the opposite side. That water rotates a turbine, which is attached to a generator that makes electricity. So as long as there's water in the reservoir and those intakes still have access to that water, then it's easy. It's just gravity, right? But the key is you got to have water in the reservoir, which means these dams have to be constantly fed water from a surrounding system. Okay. So aside from the other unwanted effects, indigenous people could lose their lands. There is the potential for diseases like schistosomiasis to form in the water. And remember, fish kills can occur from rotting vegetation in the dam. Here's some alternatives that we could use. Instead of building dams, we could do what's called a low headwater hydropower project. In this case, we extract energy from small headwater dams instead of like the mega structures, and their footprint that they leave behind is exponentially smaller as a result. We can do run of the river flow, which basically means we're going to submerge directly in a stream and not build a dam at all. Or we could do micro hydro generators, which are small versions designed to supply power to like single homes. We've even got cities now that are installing like turbines in the water pipes in city streets. So when water goes out to the community, it rotates a turbine underground and generates electricity so that we don't need a dam at all. I don't know if we're going to continue to build dams in this country, with the technology being what it is and the environmental footprint they leave behind. There are alternatives, so maybe we'll start using those. Geothermal energy. So geothermal energy is all about tapping into the energy resources, the warmth of the planet, so to speak. Geothermal energy is really easy to tap into if you live near hot springs or geysers, but that's a big if, right? Like there has to be volcanic activity like near the surface for you to tap into geothermal energy. So the biggest like con for geothermal energy is like finding it. Like you can't just drill like 70 miles down into the, Earth's crust to find like, heat that you can use for geothermal energy. It's not efficient. So, the number one limiting factor to geothermal energy, which is for all intents and purposes clean and renewable, is just having access to it. Heat from the crust should technically never be exhausted, but you gotta find like an access point. Probably the best place to access this type of energy is in the country of Iceland. Iceland's got a setup there where, for lack of a better way to put it, almost 100% of their energy comes from renewable resources like geothermal, solar, and hydroelectric power. But they're very lucky in that they actually straddle two tectonic plates that are moving away from each other. So in one aspect, they have all this access to geothermal power. And another thing that's cool, Iceland's constantly getting bigger because like they're adding landmass in its center, which is kind of neat. Okay. Tidal energy. Tidal energy just takes advantage of ocean tides and waves. Ocean tides and waves can produce enormous amounts of energy through tidal stations. Tidal stations, well, they take advantage of tidal flows through turbines to create electricity. And all you need is like a high-low tide differential of a few meters, and like you can create power this way. Wave energy could meet local needs in coastal areas in places like Scotland, Canada, South Africa, even the US, right? So it's just a matter of putting the technology in play. This is like a Palamas wave converter. Just kind of give you an idea of one way the energy could be generated using tidal energy. This is a machine that points into the waves and it undulates up and down, and the action of that undulating action with the swells pumps fluid to hydraulic motors that drive electric generators, and then cables take the power to the shore. Some people would argue that these are kind of like eyesores, and like, yeah, like I don't want to look at that, when I look out at, the ocean and the waves and all that. And what about shipping? And, there's trade-offs no matter what you do. Okay. There's also the potential for taking heat energy from the ocean. Ocean thermal electric conversion is another possible way of making electricity. Heat from sun-warm ocean layers can be used to evaporate a working fluid like ammonia. Ammonia has a much lower boiling point than water, so you don't need as much heat to get it to volatilize. Once it volatilizes, that gas pressure can spin a turbine and generate electricity, right? That might be an option for Western South Africa, Southern Pacific Islands, again, Hawaii. Biggest problem you're going to have with something like that is you can't let the ammonia like escape because it's poisonous in gaseous forms. Okay. So the other issue that we got to deal with this renewable power is getting the electricity where it is needed. So a while ago, I told you that, like when it comes to geothermal power, like we don't have access to it everywhere. So I suppose if you could find access to, geothermal power or even just a broad expanse of desert to do your solar power generation, the next issue you have is how do you get it where it's needed without losing all of the potential energy that is stored in the electricity that you've generated. Many places with the greatest potential for solar and wind power are located so far from urban centers where the power is needed that at the end of the day, like the power lines, couldn't carry the electricity all that distance without like losing the flow of electricity. You could think of electricity almost like water. So at the point of generation, like there's this big surge that pushes it along. And then as you get farther and farther away from that generation point, unless you have something that will then boost the electricity and keep it moving, it's going to slow down, right? Because every electrical wire or cord, if you will, that electricity travels through has a certain level of resistance to flow. And the farther you go, the more that resistance plays into slowing that electricity down, and you get less and less available work out of that power. President Obama is proposing or did propose to spend $4.5 billion to expand the power grid to accommodate new power sources. But the biggest problem we have with our power grid is nobody wants to look at power lines, right? Nobody wants power lines coursing through rural America. Nobody wants power lines in their own backyard. So we got to figure out another way to get electricity from point A to point B without, putting power lines everywhere. All right. So a few pros and cons for you in terms of like hydroelectric power, I want you to have in your notes. So pros to hydropower, whether we're talking about wave and tidal energy or a dam, the net energy, for production is high. There is a long lifespan. There's low greenhouse gas emissions. If we're talking about dams, you could use that for flood control, water storage, and even recreation. The biggest con for hydropower of any kind is it's expensive to build. It can impede fish migration, sediments build up behind the dam, you don't get nutrient flow downstream. You remember the list. All right. So this is pros and cons of hydropower. We're going to look at wind power next. This one always blows me away. Yeah. All right. So anyways, so wind power is what you think it is. So you use these wind turbines to generate electricity. It's called a wind turbine because basically those big blades are attached to a shaft that goes to a generator that makes electricity. So the blades themselves are a turbine. In this picture I've got for you here up at the top of the screen, you can see Altamont Pass. If you've gone to the Bay Area, San Francisco area, you've had to drive through Altamont Pass on your way there. It's one of the few places in California where we have some pretty consistent and regular winds. And so they're trying to use wind power generation there to help meet the needs of the Bay Area population. Another area is down in Southern California. They have the Santa Ana winds that can basically do the same thing for them. They're blowing the opposite direction, but the impact is still the same. Okay. So there are an estimated 80 million megawatts of wind power that could be commercially trapped worldwide. That number alone is 5 times the total current global electrical generating capacity. So we could technically live off of wind power alone. Problem would be A, tapping into those megawatts, and B, then getting the power where you need it. China is now the world leader in wind power turbine production. Okay, that means they're making more turbines than anybody else. That doesn't mean that they are the leader in production of electricity from wind power just yet. It's just they're building more turbines than anybody else. Wind turbines typically operate at only about 35% efficiency under field conditions. So, at the end of the day, there's friction to take into consideration. There's variable wind speeds. Turbines are designed to spin at a fixed speed to produce maximum electricity, and that requires consistent and constant wind in order for that to happen. When conditions are favorable, electric prices from wind power can be as low as 3 cents per kilowatt hour, which is downright like dirt cheap. Okay. When you think about wind power production, it's going to involve lots and lots of turbines, which some people, again, will argue is an eyesore. But like anything else, there are trade-offs. Some of the other cons for wind power production is that there is an initial upfront expense to produce these turbines. Believe it or not, some people argue that they're loud because they make a swooshing sound, when the blades spin. And again, I probably shouldn't laugh, but birds fly into them. Okay. So, part of me wants to say that's natural selection, but, the other part of me says, like, I feel bad for the birds because, that's not something natural in their ecosystem that they recognize as a threat. So they go flying into this thing, and that's the end of Tweety Bird. Okay. So pros, there's no fuel costs or emissions once they're installed. It generates income for farmers who maybe could rent the land for the turbines and sell electricity, because you can actually still use the land under a wind turbine. You don't have to sacrifice your whole field like you would if it was solar. And there's a very short planning and construction time, because really you just have this footprint, and that's it. Everything else is up above where you could be like raising your crops. Cons, wind is not 100% reliable. There's not enough wind everywhere. There's bird mortality and power lines that are needed to transmit the electricity where you need it. Okay. So, no matter, whether you wanted to write it down from that slide or this one, you do need to know the pros and cons of wind power. Okay. There's noisy on there as well. Okay. All right. Biomass. So biomass is all about using living material to generate, gases that we use to then create heat, to boil water and make steam. So when you think about biomass, we're going to be burning wood, garbage, crops, maybe alcohol fuels, landfill gas, stuff like that. Okay. Plants can capture about 0.1% of solar energy that reaches the Earth's surface. About half of that energy is used in metabolism, and then the rest is stored as biomass. Useful biomass production is estimated about 15 to 20 times the currently obtained from all commercial energy sources. And remember, we can burn anything like natural. So wood chips, bark, leaves, starchy roots, all that can be burned in biomass. Probably the biggest sticking point for biomass is the fact that you are burning something. And if you have a place that, has issues with air quality, you're going to have to be conscientious about that and spend extra money to clean the exhaust that's coming out of your power plant. Okay. So we can burn biomass. Recently, as 1850, wood supplied 90% of the fuel used in the United States. In poor countries, it's still a major energy source. Even in rich countries, wood-burning stoves are still popular in response to rising oil prices. The Danish islands, they get about half of their heating and ag waste from ag waste and from biomass crops. Some utilities are installing flex fuel boilers that will allow them to burn coal or biomass, which takes a little bit of stress off of the fossil fuel industry. So that's good. The U.S. is taking steps to increase ethanol production to kind of keep pace with countries like Brazil. Ethanol is a fuel that is made from biomass, right? And instead of using gasoline, we can burn ethanol in our vehicles. Methane is the major component of natural gas, and it's produced by anaerobic decomposition. So anytime you take, products, whether it be, wood, leaf litter, or, ag waste, and you allow it to ferment, you can actually produce methane gas. Probably the most interesting example of methane gas production I have seen was on a trip to a wastewater treatment facility. The bio waste, we'll call it that, as it fermented, produced, methane gas that was captured, put into a generator, and used to make electricity to run the plant. So, methane was kept from entering the atmosphere, which is an awesome thing. While methane is a clean, efficient fuel, it's also a potent greenhouse gas. So 20 times more potent than something like carbon dioxide. So you don't want this stuff to just vaporize out into the atmosphere. Municipal landfills can contribute as much as 20% of annual output of methane to the atmosphere. So rather than just let that go up into the air, we're going to try to capture it and burn it for electricity. This is an example of what's called an anaerobic digester. Okay, so basically you take whatever organic material that you want to ferment in an anaerobic environment, you put it in a huge storage tank, and in that storage tank, okay, you allow bacteria to basically do their thing, and as a result of breaking down that organic matter, gas is produced that will then be collected and can either be used for cogeneration, or as you see here, this one's just being burnt off by a torch. Okay, but better to use it in cogeneration, right? Cattle feedlots, chicken farms, these are all tremendous potential fuel sources for bio waste. Basically, you could collect all of the animal manure, put it in an anaerobic digester, produce tons of methane, and then use that to generate electricity rather than just let the stuff become fertilizer. Okay. Biofuel use can even be done on campus. A number of colleges and universities are weaning themselves off of fossil fuels. Here's a few examples. Middlebury College in Vermont uses wood chips in a gasification plant to heat the campus. University of New Hampshire is working on a plan to heat the campus by burning methane from a nearby landfill. So there's huge potential here. Ethanol and biofuels can enhance our fuel supplies. As you saw, the U.S. and Brazil are both working hard to increase ethanol production to take the strain off of fossil fuels. So the deal with this is you're going to take a food crop like corn or sugar beets, and you're going to ferment that to make ethanol, and so that can go in a gas tank of a car. The biggest problem that you run into there is that if you're growing soybeans, or corn or something like that for ethanol production, well, that takes land out of production that could have been producing food for people. So again, there's trade-offs. 1/5 of all corn grown in the United States right now is used for ethanol production. If that number goes up, then that means you're going to be losing food production for people, either directly eating corn or maybe like feeding cattle. Okay. Biofuels does, have the potential to grow into new areas. There are shrubs native to Mexico and the Caribbean that produce nuts that are high in non-edible oils that can be, used for biofuel. Jatropha oil is easily converted to biodiesel, which again would take the weight off of the fossil fuel industry. Unfortunately, trials elsewhere have shown that JAPRO water requirements and sensitivity to pests and have lower than expected yields, so we may not necessarily be able to use that, with a mass application. Cellulose can also be used. Cellulosic ethanol can offer hope. Ethanol can be made from other plant grains. Besides corn, we can use wood chips and straw. Plants, again, they capture the sun's energy and you only use a small fraction for themselves. So at the end of the day, we can ferment that and use that to make ethanol as a fuel. Okay. So there are lots of different examples of where we can get ethanol. Even using switchgrass to produce ethanol could replace 20% of U.S. gasoline usage and require about 1/4 of all U.S. cropland. So there's always going to be a trade-off, right? When you think about this. Okay. We're even thinking about using algae, as a biofuel crop. You grow algae in a bioreactor, and it can produce biofuel. about 30 times more efficiently than you can get from other sources. They can be grown next to a conventional power plant, and the carbon dioxide from burning fossil fuels can be captured and used to feed the algae. I can just make like a giant chemistry set out of it, right? So there's all kinds of potential there, which we could explore in the future as an alternative energy source. Okay, so here's the pros and cons of biomass production. There's potential large supply. There's lots of waste products that we could use for biomass production. Moderate cost. If sustainable, there's no net CO2 production. The cons, well, it's potentially non-renewable because if you run out of biomass, like, what are you going to make power from, right? And the environmental impact is moderate to high because you're taking all this stuff from the environment and using it ultimately to make something like ethanol or methane gas. You will lose or impact habitat, and you will lose cropland, and it can be expensive. All right, ladies and gents, I think I've exhausted all the different potential options for renewable resources for you. I hope this has opened your eyes to at least some other alternatives that are out there besides just solar or wind power, and that you've learned a little bit along the way. Okay, so keep working hard, keep improving your energy efficiency, and keep looking for alternatives. Remember, reduce, reuse, recycle. I'm Mr. Kennedy, and I will see you next time.